I think you solve a very important problem. But how did you come up with this great idea to found this company?
Yeah, so I think an idea like Tala doesn't come together overnight, right? It was many months of research into various aspects of the way the web worked, the way e-commerce was taking off, and really finding fundamental vulnerabilities. And I talk about some of this in the RSA talk, but at a fundamental level, if you look at the way the web works today, if you look at the way websites or web applications work, they have changed fundamentally since the last 15 years. And if you look at the technologies that people are using to protect websites and web applications, people talk about the web application firewall, for example, that was invented over 15 years ago, right? I mean, we all remember, I think it was in 2004 that I got the first kind of free beta trial for Gmail, right? And I remember what a transformative experience it was. When I used Gmail for the first time, I never used my older email service after that, not a single time, because Google had figured out a way to make the web that much more powerful and interactive through the use of JavaScript. But today, fast forward 15 years, through a number of different iterations of innovation from Google and Facebook and Twitter and others, JavaScript has become the de facto language of the web.
Yeah,
that wasn't the case when you had technologies like web application firewall. The implication was that the modern web, as a result of JavaScript, but also as a result of the fact that we have a lot more powerful devices on our hands, meant that computation and data storage, which was traditionally on the server side of the web, was slowly moving towards the client side. And today, if you go to the average website, over 70% of the code that runs in your browser, JavaScript is actually not even coming from that particular website, the e-commerce store or bank. And so it was pretty obvious to us that you couldn't solve security challenges for the modern web, as we call it with Tala, with the same old technologies that were invented, frankly, before any of these paradigm shifts happened. So that was kind of the genesis. And then we thought about how could we solve the problem, and we looked at different approaches, and eventually we settled on what made the most sense, which was to go to Google and say, "Hi, how are you guys solving this problem?" And then we said, well, can we bring Google-grade security to the rest of the world? And that was really the genesis of Tala.
So let's take even a step back from that, because my audience in this micro format, I don't often do a great job introducing my guests. And so why don't you just take a step back and just say, like, who are you, and basically what company where were you when you came up with this company? Because I think it's important for people to see what's got you to where you are today. Just more about you personally.
Yeah, sure. So, the founding team of Tala, including myself, we're all Symantec alums.
Okay.
And I led a number of strategy projects, product development for the CEO and the CTO at that time. And that gave me kind of the incredible opportunity to look at lots of different aspects of security. We spent a lot of time looking at, for example, point-of-sale malware systems. And we all know what happened with Target in 2013, the massive breach of tens of millions of user credentials. But we knew that kind of an attack surface that was focused on physical point-of-sale systems was going to move to the online world, the e-commerce world. And then we started peeling the onion and said, well, how is the web protected today? Is there a vulnerability? And that's when we started discovering all the kind of various issues that I just mentioned about the web having changed architecturally and people still using 15-year-old technology.
Let me ask you about that, because the 15 years ago, many of my listeners are going to get that. And so you had a traditional web server, then you had an app server, database server, and then we used to put a proxy or some type of a WAF in front of that web app. It's still used today. Web WAFs you use in front of these web applications. So you're saying that the JavaScript would execute on that web tier or in the app tier in the old days, and that what you're saying that has shifted. And I think that's an important point you're making. And so where is it shifted to? Like what does a modern application architecture look like today for those that just really want to understand that?
Yeah, I mean, in a nutshell, I think you captured a lot of it. But if you think about the web, there are three elements. There's the web, the web server side, which has a database attached to it. Then you have the network that connects the server, and then the client, right? Historically, as you said, and this is always a pendulum. It swings back and forth. 15 years ago, a lot of the code execution and the data storage was on the server side. That was useful for many reasons, but it did make for an interactive web experience, right?
Sure.
You don't want to make multiple round trips and go fetch data from the server and things like that. So Google came up with technologies like JavaScript, the V8 engine, Ajax, asynchronous, retrieval information, etc., that made things a lot more interactive. I mean, I remember when I used to be a MapQuest user, and then Google came out with Google Maps, and you saw how you could move things around. All of those things were possible because more and more of the code execution was shifted from the server to the client side.
To the browser,
right?
okay.
Yeah. Now, when you had a lot more of the server compute and the storage happen on the server side, it made a lot of sense to protect your server and the databases that sat behind it.
Sure.
But as the shift happened towards the client, the browser now becomes the point of execution of code. And in fact, the modern browser actually has its own database, right? Not just an app cache, it has its own IndexedDB, for example. People are storing more information locally so that you could actually see instantaneous results of your actions on the screen and then make kind of, asynchronous calls to the backend to update databases and things like that. So the main shift that has happened is the browser is the point where code executes. It's also the point where there's data storage. And because of the incredible competitive nature of e-commerce and online retail in general, marketing teams spend a lot of time putting in not only first-party code, but also third-party code, right? So the data that's executing in your browser is not coming from your e-commerce store, your bank. Most of it actually comes from marketing tags, advertising, lots of very, very critical things that e-commerce companies and digital media companies need for their business to survive, that as a result, your website is no longer running on your code. Maybe 20% of the code is actually written by your developers, 80% is coming from third parties. All of this opens up a completely new set of vulnerabilities that you simply cannot solve by sitting on the server side. You need something that is actually monitoring actively what's happening on the browser, understanding, is there anomalous behavior? Is there malicious JavaScript? And if so, what is it trying to do? And being able to detect and block it in real time at the browser. Historically, you just couldn't do it because, if you're a bank, you don't control your end users' browsers, right? So there used to be older technologies like IBM had a product called Trusteer where you could, as a bank, ask your users to download a piece of software. Right? Nobody does that anymore.
Yeah, right.
Nobody does it anymore. So how do you secure the browser side, which is where your code runs, without putting an agent on it?
Because we have a lot of credit unions that could have 50, 100,000 million members, and banks, they don't call them members, but they'll call them customers. But I could see the challenge you guys had to solve, because essentially, how do you scale this little applet, whatever you want to call it, this little download to 10,000, 20,000, 50,000 customers or members of this bank or credit union? It would be impossible. So you came up with a different way of approaching the problem.
That's right. We came up with essentially a completely agentless approach, right? Which means that you, as let's say a credit union, don't have to ask your users to take any actions. They can continue to use their devices, whatever browser they've been using, and yet provide a secure experience for them while they're connected to your credit union or your bank or your e-commerce store, whatever it might be. So that's really the kind of innovation that Tala brought. And I should say here that we also kind of consciously took an approach that wouldn't break your website. It's very easy to break a website, very easy to break a web application. So we wanted to use tried and tested technologies. So we essentially took the approach that Google has taken internally to protect its own web applications and mission critical websites. So we said, let's see how Google did it. They standardized a lot of these controls, and we said, let's figure out a way to automate it so that any website, any web application can have the same level of security as a Gmail or other Google apps without spending a ton of time or resources, without having to hire very high-end security engineers. That's really the innovation that Tala has brought to the table here. It's
interesting because most of 82% of traffic now is SSL. So if you don't, I talked to CIOs and CISOs about this a lot, and how do we, it's actually difficult to turn on inspection engines at the firewall side because it gets in the way of users, because you got to tune the certificates that these sites that users are going to, and firewalls get upset if they're not properly aligned. And so I'm curious how you're participating in that SSL handshake and how you're looking inside that stream.
So it's interesting, right? We actually, first of all, I think SSL is a wonderful model for us to follow. In the network, we went from 0% to kind of almost 70, 80% today. It didn't take, it took us several years. It doesn't happen overnight. We want the same thing to happen on the client side. We want people to adopt standards-based client-side security technologies that are used by the likes of Google and PayPal and Facebook to protect their own mission-critical applications. We want that to be used by everybody, just like SSL transformed the network level security. For us, we actually sit on the browser itself.
Okay.
So we don't have to decrypt anything. But when we see code, it's already decrypted because
I see. You're seeing at the end of the chain. You're seeing at the very, very end. Okay.
So we're seeing it in the clear, which means that we don't have to do any of that, any of the stuff, for example, decrypting traffic, etc. We're seeing code as it executes in the browser.
Gotcha. Okay, that makes a ton of sense. So essentially, would you be your client side web application firewall?
That's one way to describe it. Yeah, I think the best way to think about it is that in the traditional web application firewall, there are two different approaches, and one of the approaches was based on signatures. So you'd have signatures for SQL injection attacks or other kinds of attacks, and you'd look for patterns and look at the requests coming from the users and block malicious requests, right? But there was another model in the WAP that was called the positive model. The idea was that you would only let a certain number of approved requests. It's a whitelist based
like a whitelisting. Sure. Yep.
Exactly.
Totally.
Now that approach really didn't work on the server side because the server, there are lots of complications.
So many dynamics at the server side.
Exactly.
Port hopping and everything, right?
But a whitelist based model is actually superior from the security perspective because you actually have the opportunity to block 0 days vulnerabilities that you didn't exist, because you're not reliant on signatures, because signatures can be circumvented, right, by the attackers. So we essentially are a positive model, whitelist-based, client-side web application firewall. That's a more technical way of describing what we do. The succinct answer here is that a positive model and whitelist-based approaches actually work on the client side, and the proof of the pudding is always in the eating. And the technologies that we deploy for our customers are running at scale at some of the world's leading websites today. And we all, Tala ourselves have deployed this for large websites with tens of millions, hundreds of millions of users a month, so that, we know that this works, right? Yeah. It's not some proprietary technology. It is relied on by lots of companies, including Google, who kind of pioneered this.
So in this model, you're not saying everything's disallowed, and I'm just going to allow these particular instances. You're allowing everything, and then finding within that allowed model what is breaking a pattern. Is that right?
Yeah, I mean, I'll give you a simple example. Let's say you go to your online bank or your credit union. You're logging you're logging into your application. You type in username, password in your browser, right? Let's say that an attacker has hosted a server on Amazon, right? And your browser is now sending that data to Amazon.
Yeah, right.
Right. We come from the AV world, and there's no antivirus engine that would block that because Amazon is the largest company in the world. There's nobody who's going to block that. But imagine that you had a security product that actually knew that for this particular credit union, on the login page, the form information should only land on a particular server, sent only to a specific domain or maybe a couple of domains. Then you don't care that it's going to Amazon or Google or any other well-reputed company. You simply know that shouldn't happen, and you can block that in real time. So that is the power of the whitelist-based model, but it depends on you being able to know what the behavior of a credit union website is in a particular credit union website versus an e-commerce site. So every website, it's almost like a fingerprint. It's completely different. And our core IP and our patented IP is our ability to quickly and continuously model the behavior of code and content and data on the browser side. And that's what we use to deliver these security policies that are then able to detect anomalies. And I gave you a very simple example, but we look at almost 100 different behaviors on every web page that allows us to then detect and say, okay, well, it looks like you're getting an iframe, for example, from a source that you're not allowed to. Why is that important? attackers may overlay their own login iframes on top of your bank's iframe.
Yeah.
And use that to exfiltrate data. It just happened a few weeks ago.
Sure.
We can block that simply because we know this is not a legitimate source of an iframe, or images, or we can also block content that shouldn't be there. For example, images and redirection. So essentially, you can do a lot if you know what the application, the website's behavior ought to be, and then look at that as anything else.
So you get do you get like a baseline? Do you need to run the product for a month, a day, a week to get a baseline to know what like acceptable behavior is?
Yeah, it's a great question. So the baselining is the way we do baselining is very innovative in the sense that we do the baselining offline. So you don't actually have to install Tala, right?
Oh, interesting.
So we can actually build a baseline synthetically by analyzing your web application from the outside. Right. As long as we can access it on a browser, Tala is able to scour through your web application. We have multiple methods of doing so to build that model, and we can do it continuously so that we're constantly updating any new behaviors. Let's say tomorrow your marketing person decides to add a specific marketing tag or analytics tag or something else. We capture it and we add it to the model. So we're doing this continuously, but you don't have to install Tala for us to be able to build that golden image or that kind of baseline, if you may.
So you are, I'm a big believer that I think our digital systems need to be, and my listeners are going to get tired of me saying this because I say it frequently, but we have a biological defense which doesn't ask our permission whether it's going to go heal a cut because we cut our finger on a glass. It just goes and deploys resources to go take care of that. So there's a lot of automation built into our biology. And when we get really hurt, we go to the hospital, and we get a fracture set and things like that. And then we're back out in the getting healed, but there's still an automatic healing process that's going on. So I really think the kind of this next generation of security has to be starting our digital systems have to start mimicking our biological systems from a blocking and preventing perspective and stop asking for permission on things and just go at it. That's why I think AI's here. I think ML's here for that reason. But it seems you've used the word blocking and taking action a couple of times, and I'm wondering if that's the model you're trying to go down as well.
Absolutely. So typically when we deploy at a customer, the customer would deploy us in reporting mode where we're just looking for violations.
Sure.
And maybe the customer would run it for a week or two to make sure we're not blocking anything that we shouldn't be. And then we go into block mode, right? We've been running on block mode for several months on some very, very large websites. But it's interesting you brought this kind of self-healing biological model because, kind of the model that we actually approached this with was, if you look at the mobile world, right? And we've been studying malware in the PC world and mobile world for a long time. The mobile world is actually very clean. It's very hard for you to infect your mobile device unless you go to some unwarranted, unauthorized Android store that's hosted in China or something like that, right? It's very hard. But Google and Apple do a wonderful job of kind of curating the applications on their stores. And when you download the application, the first thing that you get is a set of permissions, right? Like, hey, this application needs to access your camera or your microphone.
Right. Allowed, disallowed.
Only then will it be able to access your camera or microphone, right? It's a model that's based on a lot of Linux security controls. But we said, well, why doesn't it happen in the web, right? Mm-hmm. When I go to my banking application and my browser is asked to send the credentials or credit card information to a server or domain, why couldn't the web application tell the browser what is allowed and what's not allowed? Okay. And only give essentially permission that it should be. And that's kind of the inspiration when we realized actually these security controls are already there. It's just that it's very hard to configure. And so,
what would you call that? Like a permission? Like what would? Because you're like in new uncharted territory. That is it like a permission-based.
It's access control essentially.
Okay.
So SSL and certificates allow you to authenticate that the server that you're connecting to from the browser is legitimate. As we said in that example I gave you, the Amazon hosted server, command control server, the browser is going to trust that certificate. It's going to say, yeah, this is a legitimate server. The browser doesn't know that this server, even though it's legitimate, shouldn't be receiving data, right?
Right.
So if I gave access control policies, right, and say, well, your information should only be sent to bank.com or ecommerce.com, not to anybody else, then the browser knows, even though this is a legitimate server with a legitimate certificate, this isn't supposed to receive my user's credentials or user's credit card information. I can just block it. And that's really the power that we bring, our policies bring to the browser. And more recently, the wonderful thing about the approach that we've taken is Google and others are adding more and more security controls. So for example, on the web today, people are using obviously a lot of video conferencing systems, right? You give permission to, let's say, Zoom or another service access to your camera.
Yeah.
Right? You get a pop-up on the browser that says it wants to access your camera. That actually permission remains in perpetuity, and that's a permission that can be used not only by Zoom but any third-party code that runs on that website. So if one of the third parties that's hosted on that site is compromised, now that can access your camera and your microphone and so on and so forth. With our policies, for example, you can say that, nope, I'm only going to give Zoom.com access to the camera or the microphone. So essentially, it's a very fine-grained access control mechanism for the web. That's one of the main issues and vulnerabilities that we have.
So from a developer perspective, I'm looking for, like, this is one of the challenges, the skills gap of a lot of companies in the, especially in the, but in the mid-market, but certainly enterprise, there's a skills gap. Flat out, people don't really get AWS and Azure security. And there's going to be a bit of time for on-prem skills to transfer and at scale. So a lot of the CIOs want to go fast. They want to, because the business is requiring new applications. And so the developers are coding like heck, but they really are building, they're not building code for security, they're building it for speed. And
That's
so
right. You got it.
I mean, this is a huge deal now. So security has to move at the pace of the offense and still do the governance and the policy and such, but they got to go quick. And so having some mobility and modularity to the security model is really important. So it's a long story, but the point is, developers, I think we lose control of the access into these environments because they're third-party developers, they're internal developers, and they got backdoors, and they got not necessarily always malicious. It's just they leave stuff open for their convenience. So, so have you thought about that and how your product may play in that?
Yeah, I think it's a very critical kind of skill gap, and it's even more pronounced in the areas that we work on, which is application security and web application security. Typically, your security folks come from network. They understand firewalls, they understand endpoint security. When it comes to analyzing code or understanding code level vulnerabilities, usually security teams don't have the know-how. On the other hand, you have the average developer who has so much on his or her plate that they're just concerned about speed. They're not concerned about security. And then you have the second problem that the code that's running on your site isn't even written by your developers. So you cannot even go and tell them to have best practices. So how do you deal with this problem? There are 2 or 3 things that we did as a company. One was making sure that our technology can integrate into a fast pipeline of development. Right? Today we call it CI/CD. It used to be called SDLC. So if you have a continuous integration, deployment, and delivery model, we integrate with that so that as and when new code comes to your system and gets deployed, we can automatically analyze the code or the application in pre-production, for example, and push new policies into production. That's one thing. The second thing is providing as many integration options, right? So that you don't have to forklift your infrastructure. We will integrate with your existing technology stack. You're running on Amazon, you're running on-premise, you're using Apache, Nginx. We've done a number of integrations, and we're constantly working on more integrations for our customers so that you can seamlessly integrate our product into your existing technology stack. So the key takeaway for us was it's very important that security have the ability to secure web applications without asking application developers their behaviors. So in our case, the developers actually don't have to do anything.
That's such an important point, and that would help out people so much, because then you could literally, they need, like, when you're playing baseball, there's a backstop, so like if the ball gets by the catcher, it's not going to roll into the next field. It just stays within the containment area. So it's like, security sort of we have to do that so that people can play the game of coding and do this stuff, but then we have this governance structure. And
That's
so
right.
I think that's a really clever, really powerful way to use your technology.
Yeah, and I think that one of the key things for us is to be enterprise grade, right? And being enterprise grade means you have to work with heterogeneity, right? Not everybody is running on Amazon, not everybody's running on premise. There is this really incredible array of technologies, and so one of the things that we've been focused on is making it really easy for customers to see value. One of the things that we do, and listeners of your podcast should email us at info@talasecurity.io. As I said, the model that we build, we can do it without any integrations, any deployment. So if you give us a website, we will tell you all the potential issues that could affect you on the client side or the browser side.
So that's all you need, is you just need the URL, the domain of the.
That's pretty much it.
And that's really cool. So they can basically see kind of a pre-deployment how how your solution would support them. So from an enterprise level, those that have mature DevSecOps groups, essentially they can insert you at different layers of that production cycle.
That's right.
How does it integrate into other security tools? Like I saw, Splunk is obviously one of the big ones. But what is your thought on that? Like what is your thought on, because you're a blocking technology.
That's right.
Super cool. Don't tell me about it. Do something about it. Well, are you just sending an email to someone? Or are you trying to feed into Splunk? Do you kind of want to have an open API that people can use? What are your thoughts there?
Yeah, that's a very important point, right? I think we took an API-centric approach. So you have access to our UI where you can do whatever, within the Tala product, but you also have APIs because, people want to take bits and pieces and integrate it into your pipelines. The wonderful thing about our protection technology is not only detect and block stuff, we actually get an alert directly from the browser. So without putting a single agent on your end user devices, you're getting this kind of ringside view into the hygiene of your environment, right? What kind of attacks are you seeing? And all those alerts come to our backend where we analyze it. We also can integrate with your existing SIEM system, right? We talked about Splunk. So we have APIs for all of this so customers can consume our analytics, our incidents, but also say, hey, Tala, I want you to scan all my domains, and then they can just use our APIs for doing that. So essentially, we've API'd most of our functionality so that customers can essentially integrate and use Tala, consume it the way they want, the way that makes sense for, and sometimes it's different from one team within the enterprise to another.
So for someone to get started, basically, and we'll give them people on the blog post that we publish this on, we'll give, how would you prefer people to reach out to you? Did you say info@tala.com, or how does?
So we offer a demo, which actually you can sign up for on our website.
Okay.
Our email address is info@talasecurity.io. You can shoot us an email and say, hey, I manage www.commerce.com or bank.com. I'd like Tala to do an analysis for me, and we can do that. And we'll tell you all the different third parties. We'll give you a snapshot of data exposure, right? One of the things that's jaw-dropping for a lot of our customers, because our analysis is very fine-grained, we actually analyze all the forms on your website. And we can actually go in and say, look, your user's username and password is exposed to these 60 different third-party JavaScript libraries.
Wow.
That's an exposure you should care about because, a lot of people talk about GDPR and CCPA, right?
Yeah.
And the focus traditionally has been on the data that's already inside your environment.
Yeah, that's where you get like the security not pen tests, but for the web application security tests,
right.
Which are so
people
tough.
Focus on who are you exposing data to, but the reality is most of the customer-centric data you collect is collected at the web interface. And the poster child is British Airways, is the single biggest, the biggest fine, GDPR fine till date, was imposed not on Google or Facebook, as some people might think. It was actually British Airways. Mm-hmm. And it was a JavaScript-based client-side web application vulnerability that got exploited. They lost 500,000 user credit card information. Even with CCPA, which came on board earlier this year, we're already seeing class action lawsuits. And one of the first class action lawsuits was a couple of e-commerce companies that got hit again through JavaScript-based client-side attacks. So this is a problem that we are
in New York
seeing
City too. New York has a pretty tough standard now as well.
Yeah, like we talk about COVID obviously a lot these days, and because of COVID and other factors, people are shopping a lot more online, and hackers are reacting very quickly. So, as people were trying to beef up their kitchen and kitchen appliances, Tupperware, NutriBullet, all these websites got hacked instantaneously right after COVID started because people were transacting a lot more. So the scary part, I would say, is it's so easy and so quick, how easy and how quickly the attackers are able to go in and compromise a website. And it's because of these sort of third-party vulnerabilities, third-party code-related vulnerabilities that are so hard to manage. Yeah. And so we really think that this problem, if it isn't solved properly and quickly, it's going to affect trust, on the internet. And that's why the PCI Standards Council actually came out with a bulletin. The FBI came out with a bulletin a few months ago that said, look, if you're an e-commerce site, if you're a banking site, you need to focus on these client-side JavaScript vulnerabilities.
Yeah, I love this. I love this because our security bulletin goes out weekly, and I have quite a broad array of guests that come on my show, as you probably have seen. But I love that you and I have talked because we've been getting a lot of feedback from folks that they really like when we bring the latest technologies and ideas and thoughts to them because they really need to see what you have to offer. And I really appreciate you spending time with me today. I really do, Aanand. And is there anything that I missed asking you that you were hoping I'd ask that you wanted to wrap up with?
First of all, this was a thoroughly enjoyable experience. Your questions are so perceptive. And I truly hope that, at the end of the day, we want to help customers, right? And we take a standards-based approach. So if customers they had a question, hey, how do I implement it for our web application, right? Like independent of Tala, we're happy to help. We want to be an evangelist for client-side web security, just like as we talked about SSL TLS. We want that number to go from the 2% it's at to 100% in the next 3-4 years. So, email us, reach out to us. We'd be happy to do a demo for you. Ultimately, this is an important problem, and your front-facing web assets are the first things that attackers are hitting. So,
yeah, I love this because people want to move into the cloud and they want to move not slow now, but we've started our hands. A lot of hands are forced. They want to go quickly, and they've got to be able to have that guidance around these. Just because you put your systems at Azure and Amazon doesn't mean that it's secure. In fact, it's written there. It's written in the
right.
We are not responsible for your data.
It's a shared model.
Yeah.
It is a shared model.
Yeah, the shared responsibility model. But Aanand, thank you for coming on the program today. I appreciate your time.
Thank you.
Okay.